very good afternoon, ladies and gentlemen, esteemed guests and audience. I extend a warm welcome to the Water Sustainability Campaign, uniting around fair and sustainable use of water. Today, we gather here at Jacaranda Hall, IHC, to address one of the most critical issues of our time, water sustainability. I am Harshita Kaur, Research Associate at TERI, and I am honored to be your Master of Ceremonies for this event. Today, we come together not only to celebrate the achievements of individuals and organizations, but also to ignite a collective passion for water conservation and sustainability that will ripple out across communities and generations. Let's commence our program by first acknowledging the importance of nourishing both our minds and bodies. And I hope everybody has had their lunch and we are ready for the program now. As we gather momentum, it's time for some insightful introductory remarks. Please join me in welcoming Ms. Priyanka Vadrevu, Research Associate, Water Resources Division, TERI, who will kick off our event.
Thank you, Harshita. Thanks for the introduction. Ladies and gentlemen, a warm welcome to everyone present in this August gathering, an event being organized on the auspices of Water Sustainability Awards, an occasion where we come together to recognize and honor those who have made significant contributions to advancing water sustainability under the umbrella of Sustainable Development Goals. Today, as we gather on the occasion of World Water Day 2024, we are guided by the United Nations theme for this year, Leveraging Water for Peace. This theme underscores the vital role that water plays in promoting peace, cooperation, and sustainable development across the globe. India, a country facing significant water challenges, has been actively pursuing reforms to address the issues of water scarcity. I was reading an article in the morning today and I learned that Bangalore's civic body has banned pool parties and rain dance for holy celebrations. And I was thinking, why do we need a ban? Why this ban has to come as law and order rather instinctively from ourselves as responsible citizens. It takes a lot of water to get our food from fields to fork. And we know that our diet makes up the largest part of our food water footprint. So, achieving water sustainability requires the collective efforts of all stakeholders, from governments and policymakers to industries, communities, and civil society organizations. Each has a role to play in safeguarding our water resources. Collaboration and partnership among these stakeholders are essential for addressing the complex and interconnected challenges facing our water systems. Today's event, the Water Sustainability Awards, celebrates the achievement and contributions of individuals, organizations, and initiatives that are leading the way in water sustainability. We will start our celebrations with an interesting panel discussion on water use efficiency, which will be followed by unveiling of a policy brief on benchmarking industrial water use efficiency in India, an important work which TERI has recently completed addressing opportunities for water intensive industries in the country. And in this context, we'll be signing two MOUs, one with Maitri Aquatech Private Limited and another with 2M Shan Engineering Solutions Private Limited. Thereafter, in the evening, we'll move towards witnessing the moments, cherishing water use efforts of water warriors during award conferment ceremony. I'll request you to celebrate the World Water Day tomorrow with the thoughts that yes, I have taken significant efforts. My efforts have won water sustainability awards, but still there is a lot which is left to be done. We need to further expand our efforts. We need to expand the contributions we are making towards the water secure future. And this expansion has to be done at a faster pace. And we need to focus on channelizing, strategizing, and importantly, leveraging water for peace. With this, I wish you all a very happy World Water Day. Thank you very much.
Thank you, Ms. Vadrebu, for setting the tone of our discussion and guiding us through the agenda for us today. Now, I have the pleasure of inviting Mr. Anshuman, Director of the Water Resources Division at TERI, to share his opening remarks and officially inaugurate our event. Please come, sir.
Thank you, Priyanka and Ashta. I join my colleagues in welcoming you to this particular function. It's more of a celebration, it's more of a responsibility, as well as our experience sharing on various perspectives of how we look at water and how we use water, how we are related to water. Um, as you might already know that this particular year, the theme is Water for Peace. And a lot of perspectives on peace has been emphasized on collaborations. While at TERI, we have been working with various stakeholders at different levels, the government, the state government, the central government, the bodies at the cities, as well as the grassroots level farmers and local residents. The entirety of the sustainability basically cannot be achieved until the last mile connectivity has been achieved. And that's where the importance of collaboration comes in. I mean, if you look into the challenges that across the world and as well in our country is, in the water sector, I can go on enumerating right from the declining per capita water availability to the efficiency of water use, something that we'll be discussing in a while in the session, how we are inefficient still as we have a lot of initiatives taken up. Our agriculture best of the command area programs are at best, around 38-40%. It is improving, but we still have to go a long way. Look into the domestic sector, the non-revenue water, the leakage losses into the system are anywhere between 30 to 40%, 50%, even more in some cases. And therefore, a lot of initiatives on service level benchmarks in the cities have been taken up. If you look into the industrial sector again, there is a huge opportunity of improvement. While there are some very good examples already, big corporates, big companies have initiated a lot of activity on water use efficiency and conservation. But as we will exemplify through our own work, you'll realize that possibly the opportunity, the scope still is a huge, large. And that's where the cooperation again comes as an important perspective. Now, the kind of studies that we have done, the range of opportunities in terms of innovative technologies, in terms of process modification, opportunity to improvise on the use efficiency within the industrial processes, all of these exist in a huge lot. And they are also the kind of interventions based on which there's a huge opportunity by which the industries can reduce their specific water consumption, which is essentially how much amount of water is being consumed per unit of the product. So all of these good examples, these policies and programs are not going to bring out that impact unless there's a good kind of collaboration, dissemination of the information. And that probably is one of the reasons why we have gathered over here in this particular uh, event. I'm also, kind of reminded of the kind of, initiatives that we have recognized, through the, water awards, the kind of good amount of innovative work and the excellent examples of water efficiency and water conservation related work in the water sector, which you will see later in the day, the champions of that being recognized for that. And all of that, all of these good examples, all of these best practices has to be disseminated to a wider lot. We are just representing a few, while this has to disseminate to a much wider population, be it industrial sectors, be it our own folks around the villages, or be it cities of class 2 or class 3 or further on, who need to learn from some of these examples and best practices that are across. And I think that's something that I would want to emphasize in today's event. Of course, there will be numerous amount of examples of technologies, best practices, policies as well, which will be discussed. But I would rather emphasize that all of you are here. You have been championing your initiatives in working in the water sector. Try and see how we can collectively disseminate the information, share our experiences, share our best practices to the last mile so that this critical mass impact can be achieved. And with that, I really once again welcome you all. We'll be discussing more on different session. I think the session that we are having is on water is efficiency, uniting for water. And I think that's a very important message that we want to kind of, discuss through this particular session. Our session basically is, I think you'll introduce the session? Okay. I leave my colleague to introduce the session. But thank you. Thank you again for coming over.
Thank you, Mr. Anshuman, for inspiring words. And next in our agenda is we have a captivating panel discussion lined up, moderated by none other than Mr. Anshuman himself. Let's welcome our esteemed panelists, and I will request the audience to give a round of applause while I name the panelists here. Dr. S.K. Sarkar, Distinguished Fellow, TERI, and former Secretary. Please, can we have him? Mr. Manish Gandhi, Senior Vice President, Iron Exchange India Limited. Mr. Dilip Singh, National Project Manager. And Mr. S.S. Kakar, ex-General Manager, NTPC Limited, to share their expertise and perspectives on water use efficiency. The panel is yours, sir.
Thank you. Well, as I mentioned, we wanted to start with the discussion on water is efficiency. And as my colleague has introduced, we have an eminent panelist, a set of speakers who are experienced in their sectors a huge lot. Dr. Sarkar, as was told, that he's been in the water sector since, and I think a whole 30, 40 years. He's been Secretary, Ministry of Water Resources as well earlier, had been guiding us. Mr. Manish Gandhi, really like to thank him for a very short notice, but he has agreed to be here. Huge amount of experience on industrial technological perspective and innovations in the treatment of water, and therefore the possibilities on usage and therefore improving the efficiency and wastewater recycle reuse. Mr. Kakar has been with NTPC and so he has vast experience on water use and some of the innovations that are there already being taken in the NTPC as thermal power plants is something that he might want to share as well. And of course, Mr. Dilip, who will bring in the perspectives from rather, international experiences and the, kinds of, experiences in the water use and efficiency from the UNDP perspective. If I may, I just thought we'll start with a discussion on the use efficiency. Again, as I mentioned, there are different sectors. One can go on discussing the issues in each of them. But something that we have recently completed, we wanted to have a discussion on that, which is benchmarking water use efficiency in industry sector in India. We had taken up 4 sectors, which is thermal power plants, pulp and paper, iron, steel, and textile. And I do want to give you a flavor of it. There's a huge lot of discussion details. I don't want to go into that, but rather the key messages, because I want to hold more time for the panel discussion. So, these 4 units, these 4 sectors, we had gone through their different capacities and, different kinds of and types of raw material based kind of production that they had. And we audited them on ground, looked into the available secondary data across the sectors. And based on the audits that we have done, there's a huge range of opportunities that we identified, and that's what I want to share with you. For example, in case of the thermal power plants, those of you who might be aware about the process, basically you use huge amount of water for cooling of the cooling towers, as well as ash handling, which is something that is used very in a huge way in power generation process. Now, the range of opportunity that existed, included, for example, the recirculation of water from ash dikes, system back into the system. So therefore, reuse and recirculation of ash handling water, as well as increasing the cycle of concentration, as it is called, which is basically reusing more number of time the water used for cooling purposes within a closed loop manner. But then there are other opportunities as well. For example, the amount of wastewater that was generated, being discharged out of the system without any reuse could very well be reused. By the way, I'm just enumerating some of them. Some of these NTPCs and the power sectors have already taken this up. But I think, as I said, this is more to be disseminated to the wider, larger group so that everybody is able to pick up the. So therefore, the best practices and the kinds of interventions makes a huge relevance over here. And then there are aspects related to, for example, rationalizing of the water use in the colonies of these industries. Wholly in all, there's a huge amount of possibility of saving water. And again, if you look into the best practices, you'll see that, for example, in the thermal power sector, dry bottom ash handling, use of hydrobin, concentrated slurry disposal systems, dry cooling, which is though difficult because there has to be a trade-off between power generation and the water conservation, but then this is as well a possibility. And then, of course, other interventions. And there are other indirect approaches, for example, increasing the operating temperature and pressure, the steam parameters, basically, the supercritical power plants have it, and cogeneration processes, for example. Now, all of these are details, but what I wanted to highlight was that in the short term and the long term, we identified there are some of these very low-hanging fruits. For example, recirculation of ash water, and increasing the cycle of concentration, which is more about recycling the cooling system water and reuse of wastewater. This alone can save a huge lot of water because almost 70% is, or 70 to 80% water in the thermal power generation process is between the cooling system and the ash handling system. And then, of course, the long term between dry and ash handling and the dry cooling. These are the kind of benchmarks based on the identified interventions as well as the potential opportunities, things which can be implemented on ground. We have identified based on different capacities and different kinds of options. But I also want to highlight that many of them actually are financially attractive proposition as well. As you can see, there's besides saving a huge lot of amount of water, there's also a fairly attractive financial saving as well. So it makes a huge sense to take up all of these specific, intervention, which are possibly the low-hanging fruits which can be adopted in this particular sector. There are initiatives by the government. For example, under the power tariff policy, the power plants have been mandated to, basically use this treated sewage from within the 50-kilometer radius. And there are many other, interventions which have been suggested. I think that has also helped in basically guiding the industries towards the benchmark process. Likewise, in textile, again, I'm not going to go into details of the process. We looked into the, water use in the textile, processes. And in the entire process of dyeing and, right from yarn to the fabric to the dyeing processes, there's a huge amount of water consumption. I think the summary of, the range of intervention that you see over here is how we can recirculate and reuse the water within the processes when the processes are, taking place. For example, in dyeing, for example, in your, washing processes. So counter current is one of the example. Again, not going into technical details of this. The point is, there's a huge amount of opportunity for reusing the water within the processes while it is being used, and as well as after the process, basically treating and recirculating it within the system to reuse from various, in various processes. Now, there are examples within textile, for example, a highly efficient CIM machine system, which actually optimizes the water use. It's being adopted by some of these industries, but can be widely adopted in the sector. And therefore, again, that critical mass impact can be achieved over here as well. Details of the kind of intervention. These are the benchmarks that we have kind of derived out of our study, which can be achieved. By the way, this sector and the pulp and paper sector has moved a long way. Just to give you an example of, again, this is the amount of financial saving as well as the water saving. Again, sector-specific recommendations, not going into too much detail, but initiative of the government has been quite, CPCB has taken a good lot of initiative in basically interacting with the both textile and pulp and paper industry and trying to share and in a way, guide, implementation of the best practices in this sector as well. And that has actually done a fair lot of, impact on the sectors. Pulp and paper, there was a time when pulping process used to take a huge amount of water. It was largely 80% in terms of the consumption of water during that particular time. But over a period of time, I mean, some decades now, pulping process has, been really improved a huge lot. And now the water consumption has, been very, very less, almost 20–30%, because it's more of the reused material that is being used in which pulping is not required. And as well, the removal of the, color and the lignin. So again, the same process, but, as you can see, different kinds of process consumption, water consumption, and opportunities. In this particular sector, for example, in the pulping process, dry debarking, improving the pulp washing technology, de-inking process, flotation de-inking process, and as well as, for example, introduction of new technologies like dry pulp for cure form paper, which is almost near waterless, and likewise, the kind of technology. Likewise, in paper making, again, there's a save all clarification system. Essentially, what you do is you collect the water, after the process and reuse within the system. There's a disfiltration system wherein what you do is you basically use nozzles and, filter the, water, and you get 2–3 kinds of water in terms of different purities, and then you use it according to the purity. The purest form is basically reused into the system. The less pure is basically further treated and again reused into the system. Now, all of these are, interventions which we found very, very useful and has a huge amount of, water saving potential. And therefore, no wonder, applying these brings in a huge amount of water saving, and therefore the potential for, reduction in specific water consumption. Likewise, again, you can see huge amount of water saving as well as financial saving. Iron steel, likewise, again, processes are, in which you use, electric arc and, blast furnace processes. A huge amount of water again is used in, in this particular, industry. Sorry, and the opportunity again, while there are other opportunities as well, some of which are already there, what we found was that some of these most impact-making interventions was like coke dry quenching, which is basically, although a bit costly, but has a fairly good payback period of between 3 to 4 years, 5 years. But it gives you a huge amount of water saving as well. Besides, of course, the recycled reuse of cooling water, dry gas cleaning, as well as the wastewater reuse recycle as opportunity. Now, Vizag is doing that. Many other industries are also doing that already. And therefore, there are some best examples which exist in the sector already. So these are some of those ranges of, interventions. Again, not going to too much detail, but as you can see over here, a huge amount of, efficient water use can be achieved. And therefore, we identified the benchmarks to be fairly, lower than what exists now. Now, all in all, we had therefore looked into the kinds of, technical interventions which is within each sectors which can be adopted. But in general, if you look into optimizing township water supply, regular water audits, metering, monitoring, rainwater harvesting, as well as updation of the technologies, automation, recycle, reuse of treated wastewater, benchmarks. All of these are things which are required to be taken up, not only from the industrial perspective, but also from the policy perspective. What we also have recommended in our policy brief is about incentive mechanisms to be there. These benchmarks can be adopted and further taken, to the other industrial sectors as well. The perspective of recycle, reuse of water, and in that sense also the rational pricing of water, not only water but also wastewater now, because that as well is a resource, is something that is very much required to be there from the policy impetus perspective. Besides, of course, as well, the strengthening of its institutional and monitoring capacity. So I'll stop here. These were some of those key highlights of the detailed study that happened for almost 4–5 years in practically, if I exclude the COVID time. But we are very happy to have the support of the industries in this process, as well as the Ministry of Water Resources, National Water Mission in particular. Would like to thank them who were key to initiating this particular study. Now, I wanted to give a flavor of the kinds of opportunity if one would want to go in detail in various sectors. And this is something that I would want to initiate through a discussion as well with our esteemed panel. I mean, this particular discussion is not necessarily only focusing on industry. This is some of the work that we have done in the recent past. We'll also be launching, or in a way unveiling, a policy brief in a recent while. But may I then open the panel discussion and invite Dr. Sarkar to share his thoughts and experiences. He has a vast amount of experience in interacting with industries, interacting with stakeholders at both the ends, within the government and outside the government. He has been also guiding us, and I think Dr. Sarkar, we would like to hear from you, besides what you want to speak, as well also, how do you see the policy, for example, in particular, can be further, so that we have that, as I'm saying repeatedly, that critical mass impact. How do you think, and what do you think are the critical things that are needed to promote that? Please come over and share your thoughts besides this particular question, if you may. If you want to, you can speak from there.
Thank you, Anshuman. If you recall the events which have taken place all over the world, I am just referring to 2016, January 1st, when the Sustainable Development Goals were introduced all over the world, and India is being a member, was committed to implement the objective of these SDG goals. If you look at the SDG goal number 6, the clean water and sanitation, talks about various targets. There are 8 targets. One of the targets 4, 6.1, 2, 3, 4, is talking about water use efficiency. And as a result of this process, and also the earlier initiative of the Government of India, the water use efficiency is one of the objectives of the goals of the National Water Mission in India. Now, and TERI was chosen for that, to do this kind of study, benchmarking industrial water use efficiency study, keeping in mind the Sustainable Development Goals and the Government of India's initiatives in this regard. As all of you know, that in industry, the water demand is going up and up. 2050, it was estimated that the industrial water demand will be around 13%, which will go up from 6% in 2010. So as a result, you will find that demands are increasing, but the water supply, which are the water available supply, is limited and finite. So if the water is finite and the demand is increasing, how will you meet these two sides of the balance? As you know that, particularly in the industrial sector, the economic value creation for water unit use of water is $7.5 in India, which is very low compared to the international standard. For example, in UK, this number is $443. Ours is $7.5 and the UK is $443. So that means we are using more water for production, for processing, compared to the international standard. So there is an enormous scope for handling this subject from industrial point of view in India. In our system, in industry, as all of you know, that the power sector consumes the most part of the water demand in industry, followed by engineering and paper and pulp, steel, etc., textile, which Anshuman has just mentioned. So if you see the use of demand and the way it can be reduced as per the recommendation given earlier, the question is that how one can incentivize the industries. Industries are having water use in their own way, and if there is an opportunity, they can reduce it. But how to create that opportunity as a matter of principle on the part of various industries? This is an issue. This is a big policy issue. In government, there is a water use, Bureau of Water Use Efficiency has been constituted. The question is, would this be enough to give an incentive to the industry? Is the industrial water use efficiency, who will implement that? What is the role of the regulator? Is regulator has any enough opportunity to work on this? And if the industry does, by using improved water use efficiency, what are their incentives? So these are the questions which are coming to the mind of the policymaker as a follow-up of the recent study on the subject. In fact, there are many opportunities. As you know, water is a state subject. There are central industries, there are state industries, there are MSMEs, etc., etc. And the government's initiative, the Make in India program, has made the industrial demand much more than what we have seen in the past. It will be much more in the coming future. So if that is so, how one can introduce this benchmark, this water use efficiency concept into the industry? Do you think that the regulator can do it? What is the role of the regulator? Is the regulatory initiative enough? What is the role of the industry on their own? So these are the issues I think we need to discuss and take a view. In fact, it is true that there are many industries who are taking initiative. Water neutrality is a concept which is coming into the industrial arena. And many industries are taking initiative on that. But those has to be percolated to the other industries. Those who are taking initiative, they are doing very good work. And in fact, we will be discussing some of them in the next session, few sessions. But those are not enough. This has to be increased, expanded to the other industrial sector in India. Only then we will be able to say that our demand will meet the supply, water supply. So let me stop here and let us hear the other members. Thank you very much.
My pleasure now to invite Mr. Manish Gandhi, who's a Senior Vice President at Ion Exchange India Limited. As I said, he has a vast amount of experience in, not only in technology, but working with various sectors in providing solutions. Very keen, Mr. Gandhi, to hear from you the new developments as well as your past experiences in the subject. And feel free to share your experiences on efficiency and how we can further, disseminate and, upscale the initiative and the interventions and the innovations that you have come across with.
Sure.
Thank you.
Eminent speakers on dais, ladies and gentlemen, good afternoon. Namaste to all. It's indeed my pleasure. I'd like to thank Dr. Anshuman for inviting me to make presentation on such august gathering. and very important subject and topic of water conservation, how we can conserve water, how we can reuse water, because it imposing a big challenge to the country's existence in terms of economy, in terms of agriculture and all. I'll make a big presentation because the time allocated is very less. I'll not talk much on about my company, which is being the first water treatment company of India. And we started in 1964 and just completed 60 years of our existence. So we were one of the best and finest companies in the beginning, and even today we carry that flagship. And every technology, in fact, no, I'll not say every, it will not be justified, but 85 to 90% of technologies in India are by an exchange. Everything. Today, when we are talking about recycling, who made it feasible, right? So I'm going to come and touch these topics. So we are one of the Asia's biggest water and wastewater company. And we have got more than 1 lakh installations, almost 400 large power stations or fertilizers, refineries, petrochemicals, steels. I've got plants for mining. Apart from that, medium, light and all with more than 1 lakh installations. We have got 7 manufacturing units across India, about more than 2,000 people working in the company with another 3,000 people on our own payroll. We have got two big R&D centers in the country, actually big R&D centers, because this company is surviving because of technology, because we keep on coming up with new technologies, new solutions. Why? For the sake of industries only, for the sake of human mankind, and for the sake of maximum efficiency, what we can deliver to our society and the industries, So topic is again how we can conserve water. But before I say one or two more, show one or two more slides on recycling, use and other things, I just want to share one very important information that recent economic survey, this is by the government, right, in this study which came up. So it was mentioning that water crisis is brewing below the ground and up in the sky. So India is getting affected from both. So we are getting affected because of depleting water below the ground and by rain, which is again a matter of consideration. So there are 5 different integrated aspects which are a result of the water shortage. The first and foremost is the rate of groundwater depletion in India is the highest among the world. Now, this is a very, very serious concern. This depletion is something, in spite of the fact we know this, these are the studies by the government, still it's rampant. There are no controls on it, Even in cities like Delhi, which is the capital and heart of India, So this is something, and when groundwater extraction is becoming more, so groundwater table is something which is cause of concern because it's going down day by day, I don't know whether you know or not, how much is the TDS in the Connaught Place area, in the groundwater? The Connaught Place, which is something, one of the most beautiful places in India. How much is the TDS in the groundwater? It's fluctuation between 8,000, 10,000. That too, one has to go 400, 500 feet deep into it, So and so is a serious issue. And nevertheless, it started like with Bangalore, How today it has been asked to the employees, go and work from home. Statement is not finished over here. Go back to your home. Like work from home, but go back to home. So guys also are from other regions, ask them to go home and come back to your parents' house, operate from there. So and so, see something, this is like a global map. It's an IT hub in the world, and see where we landed. So this is something, a very serious issue. So this is impact of water depletion, not only in the urban sector, it is in the villages also, because everywhere, surface water supplies are not available. So, withdrawing of the groundwater from rural urban areas causing the equal challenge. Third is due to rising average temperature. I hope you know that we do talk about environment sustainability, and this is something a hot topic throughout the world, and all top premiums are discussing this. So this is also a cause of concern that there's a temperature rise and there is a decline in the rainfall. So there is no clear-cut time period for monsoon now. Earlier there was like, suppose if you talk of north, so it used to start from 15 July to go up to 31st of August or something like 1.5 months. If you see that duration is reducing day by day, right? Then rains were used to be on daily basis, but now it is very scattered. It may rain very heavily for 1 hour, after that it will not rain. So those, irregular patterns and completely scattered, way of it, has also led to the, less water which is going to the ground and resulting again, the depletion is not covering up. So even monsoons are getting hotter and drier. This is a very serious issue. And there are a lot of graphs shown into it, cold days, wet days, hot days and all. I don't have time to go through each and every slide. It's something like, facts which have come out from the government study, which I wanted to highlight. So this is something, the status that especially the north and the central part of India is very much affected. I'm also handling East region. By God's grace, they have got enough water. But then central and north is something, almost, and south, almost three-fourths of India is really going through water crisis. And what we need to do, look, I come from the industrial perspective. We work for all industries. There are about more than 21 kind of industries, industrial segments. So we work for each and every industry, and every industry we now focus on the first water treatment plant which we install, how efficient those water treatment plants are. With the recovery is maximum. Suppose I put them an RO plant, reverse osmosis plant. So we make sure whether it's a small industry or big industry, the RO recovery should be as high as 90%. The wastage should be as low as possible. Then water which is getting wasted also, it should go to the ATP plant so that we can recycle also. So right, we always focus on mass balancing. So first and prime most important thing is the water audit. As Dr. Anshuman has also highlighted that how important key, water audit is, because if you are not going to know what is the total water consumption, how you're going to conserve it also. When we talk of water audit, when we talk of recycling, why we talk? The objective is only water conservation. But I personally feel it's not only water conservation. When we generate effluent, and when we do recycle, of course, that's a big and major advantage that we go for the water conservation. Second major, which I feel like is the more than the first one, is we avoid adulteration of our good water resources, which are kept for our families. We are sitting here, but our family is drinking water. We are drinking water daily basis. Now, if all those resources of water, which are supplying drinking water at our offices, our residents, all places across India, should be conserved. There should not be any adulteration. And since there is adulteration, there are industries, those who are not focusing on these kind of treatment programs. And because of that, everybody is suffering. And that number of hospitals are increasing day by day, and all hospitals are full. So this is something, an indirect impact on the health and lifespan of the people also. So this is indeed a very big crisis. And another important thing is economic sustainability. Today, when government is talking 5 trillion economy, now when we are facing problem right now, and tomorrow if you want 3 times more bigger economy, so how you are going to compensate all these kind of things? So anyway, government has taken various measures. And again, Dr. Sarkar has also mentioned one of the important thing is that how we are going to rate each and every industry, which is very vital. I think my company is taking a lot of efforts to make sure that from the central government perspective also, we're talking to ministries and all, that how we can give the ratings, blue star ratings. So this is going to come very shortly in next 1 year's time. Like when you buy any electronics product today, maybe air conditioning systems or refrigeration systems, or even fans also now, electrical items, you have found that there are some now markings, Bureau of Energy Efficiency is marking star, 3 grades, 3 star, 4 star, 5 star, in terms of power consumption, So now in that way, central government is going to come, or Ministry of Water, Jal Shakti is going to come with blue star ratings, And the companies, those who are going to have more blue stars, are going to get some additional mileage in terms of, tariff reductions or maybe, or other kind of benefits. So they're working on all these kind of policies, to encourage those industries to become water independent, Right. When we talk of Europe, America, first of all, new polluting industries are there. If they are there near the coastal areas, Second thing is there is a law, very strict law. Whatever the water quality you're taking inside your factory or industry, you can't discharge, and you are allowed to discharge only if that water discharge or water effluent which is going to go out will be better than the water which you're taking inside it. Not equivalent also. So the fresh water which you're taking it, you are authorized to discharge in case your water discharge quality is better than the fresh water. So and so is the strict rules and regulations over there. And that's how, things are very sustainable over there. But these kind of fundamentals are not existing in India. So anyway, this is something, a very important thing. So benefits of recycling is tremendous. This is something, important topic for today and for tomorrow also, which World Water Day. Water for peace, because if it cannot be peace, then definitely it's a matter of conflict between communities, between states, between the countries. It's going to take a serious turn, which we are watching from last many decades. So recycling, when we first introduced recycling in way back in 1993. So IFCO Phulpur, it is near Allahabad, is the first plant in India which has gone for water recycling. So it was in 1993, way back 40 years back. So it has not just started now, 40 years back, but sometimes, most of the companies, they take a lot of time to invest in this segment because they feel it's a waste of money, because water in North India is something, it's free, So if it is in South or in West, where the water, fresh water is very high, costly to industries, you will be surprised. The cost of water in South and West, first of all, it is not available. Whatever it is available, it is between 70 to 80, 85 rupees per meter cube. So therein justification of recycling becomes very easy. But North India is stubborn. If you increase the tariff or you increase anything by few percentage also, industry starts crying, Now, same industries in West and South have no issue, but here in the industries have a lot of issues, So where the cost of pumping is hardly 1.5 rupees or 2 rupees, So the water is so dirt and cheap, and available. So this is what is a serious issue. So reduce the wastewater discharge, remove fresh water sources, river, and protect our all these precious sources also. And many like getting environmental clearances must and all. So all this, source of water like surface water or groundwater it should be banned now for industries, No water is available for you. So either use sewage water, which is available now each and every place because a lot of ST plants have come up, or use rainwater, or use coastal areas. If your industries in coastal area, use the sea water, or any effluent which is going to come from your plant. So this is something very important. Today we are not going to follow the first scheme. If you see very carefully, that you take raw water, you treat water treatment plant, you use in process in the industries, and then effluent treatment plants, and meet the effluent treatment guidelines, discharge guidelines. वो दिन खत्म हो गए अभी कि BOD should be less than 28, COD should be less than 100. All these fundamentals should not exist now. It's, in fact, all greenfield projects doesn't consider all these kind of things. These are obsolete, absolute. So the modern integrated system is everything has to be recycled so that 90 to 92% of the water comes back and reused for high-end application. Now I'm mentioning here, except drinking for high-end applications. Yes, except in two industries, in pharma and in case of food and beverages, where ETP recycled water, even though the quality of the water is as good as fresh water, shouldn't be allowed to use in the product, direct contact with the product. Otherwise, in the rest of the industries, it can come into direct contact with the product also. So and so is about the need of the hour. And in last 2 minutes, I'll share that how we made the things feasible, but when we are talking, it's not theoretical. In fact, I visited Central Pollution Gold Board office few days back, and I was just talking to them. I was stunned, when I got some response that, sir, is it really possible to recycle the water? I said, you people are asking this question to me, and why don't you organize one training program from us? We can show you, demonstrate you. He said, no, wherever we go, all Lala says that, it is not possible. It is very expensive and all these kind of things. I said, I can share all economics with you, but everything is possible. And recycling, I explained him, started in 1993. So all our rest is excuses, Of course, it hits the bottleneck of each and every company. We need to be very wise to design the treatment schemes. Engineering should be very strong so that, it should not be compromised when plants are installed, and it should be sustainable model. So this is something, a very complex plant. It is Indian Oil Corporation. It's a joint venture between Marubeni and IOC Panipat. And first time in India, they're producing synthetic rubber. So all your car tires or truck tires, till now we were importing from outside the rubber. Otherwise, natural rubber was available, but that was too less. So this is a synthetic rubber plant, very complex effluent because chemicals are very toxic, all benzene compounds, with phenols and all these kind of structures into it. Very difficult to break down the organics. And when we talk of recycling, recycling is feasible only with the membrane technology. And let me tell you very clearly, in membrane technology, BOD, COD, oil, TSS, everything should be nil. Should be nil. If you want RO to work, it should be nil. So your pre-treatment should be so robust and strong so that you can RO, because RO removes only TDS, only dissolved impurities, cationic, anionic, sodium, calcium, magnesium chlorides, sulfates, these kind of things. So this is what these are the photographs, very compact plant because this is within inside the agriculture land, very compact plant. So this plant is in work from last almost 8 years now. And see, this is last is multiple effective evaporator where not even a drop of water is going out and the plant recovers more than 90 to 93% of the water and recycle it. So these are the influx. This is a 3 MLD plant, 3,000 metric cube per day, quite big plant. We got another order. It's something about 900 metric cube per hour plant from new expansion, petrochemical expansion coming up, and all zeros, with zero liquid discharge, not a even drop of water should come out. This is a food park of Patanjali where 5,000 metric cube per day with not a drop of water is going out of this. This is Kia Motor, these are some recent examples. And this is something last I would like to share is about power plants. As it has been mentioned that power plants consume maximum amount of the water consumption. They are water guzzlers. So therein now, as probably most of the audience knows that Ministry of Power came out with a circular 5 years back that every power plant, thermal power station, I'm talking thermal power stations, if there is a STP within the 50 kilometers of a radius, so for all clean tower applications, they're going to use water from there. Now this power plant, this is about 1400 megawatt power plant. Now with 1000 megawatt or 14,000 megawatt, the cost of investments close about 10,000, 12,000 crore rupee. It was passed, maybe right now it can be 15,000 crores also. So after making so much of investments, Nasik Municipal Corporation said, no water. Now he says that I have got only two raw material, coal and water. It's a thermal power plant. And you're saying no water, so where the investments will go? So after intervention of Maharashtra government, so they asked that Nasik Municipal Corporation has got an STP plant, which is about 25 kilometers away. You bring the water yourself, treat it, use it, and add it to your membranes. No fresh water will come to your plant because Nasik faced some drought issue in those years. So that's how this company come up with global tender. Now problem is once you install STP, right? And after that, when BOD is coming out or COD is coming out, what you will do? Are you going to install another STP? If you're going to install another STP so that BOD, COD become less than 5 or less than 0, so it is not feasible because there is no food, right? And it will be very expensive here. So we came out with the unique technology. So we call it as a tertiary treatment plant with Dynas and Dynoxy kind of filters. So which made it feasible. These are the photographs of the plant. So this is about 68 MLD plant, 68 MLD, 68,000 metric per day. So we are making it so good, the water quality, it can be act as a feed to UF and RO plant. So not only it is using as a makeup to the cooling systems, they are using as a feed to the RO plant because there is no fresh water available. So there are huge, so many case studies now. I've got not less than 40, 50 case studies now. But due to time constraint, we can't show them all. But for all segments of industries. So everything is feasible. The only thing which is required is the will. And where there is a will, there is a way always. So this is something I thought, let me show some case studies also. So when we talk of ZLD, at the last we talk of zero liquid recharge with multiple effective evaporators, right? So recycling, even if those who do not want to go for ME because it's very expensive here, but recycling can definitely conserve water up to 90 to 92.3%. So only 7% fresh water is required to run the entire premises, which is, I think, quite good. Second thing is there is no adulteration of effluent to the rivers, so that society is preserved and conserved. Thank you very much.
Thank you, Mr. Gandhi, for those excellent examples and ready technology that you shared with them. I think recycling and reuse is something that has to pick up the pace. And we keep saying that no more the terminology wastewater is to be used now. And even the ministry is now using the word used water. And like in many other countries, there are innovative ways of, mentioning the wastewater. So I think this is something that's going to play a major role. My pleasure now to invite Mr. Dilip Singh, National Project Manager, UNDP India, to come on board and share his thoughts, about the perspectives on efficiency and how he sees the larger, role of, let's say agencies like UNDP in promoting water for all, water for peace, and in general, the efficiency perspective. Feel free to share your thoughts.
Yeah, thank you, Anshuman. And good afternoon, ladies and gentlemen. So it always feels good to be back in a TERI event. I started my professional journey with TERI actually, way back in 1992. So it's like almost 34 years, 32 years now. So I've been working in the water sector, not exactly dealing with the water, but in all the sectors as energy or in the rural development or agriculture. Basically, I'm now working mainly on climate change adaptation and mitigation, but as Dr. Sarkar brought out the SDGs, so you see SDG 6 is on water, but if you see most of the SDGs actually uh, do have these water linkage. So whether it is rural development or food production or industries or even home or communities, water is an important issue, and we have been working with the water sector and dealing with what challenges of water in various sectors, both at national as well as at the subnational and at the village level as well. So we have worked with, say, national ministries at the Ministry of Environment, and we also support or work with the subnational level at the state level, in with the districts and panchayat level. So one of the things that I'll just talk about, I don't have any industries, experience, but from the experience of working in the water sector, some of the lessons that I think that we should actually take forward. One of the things that the earlier speakers already talked about is participation and collaboration. That's an important, very, very important aspect of how do we kind of, achieve the SDG goal of sustainability of water and kind of use that water for all and clean and, accessibility, etc. The other thing that I would also like to, kind of emphasize is the intent should be there. That I know the people, the participants here, the people present here, they all have the intent. But one of the things that I was happy to note in most of the case studies that Anshuman showed, the cost benefit analysis, the numbers, they are the important things of how do you make the intent if the intent is not there already from the heart. So if the cost benefit analysis or the life cycle cost analysis actually show that it is beneficial to actually work on water usage, water recycling, water reuse, then it is much more compelling for the people in the, and not only the industries. I mean, we have actually worked with the farmers and communities where when we show them the numbers, then they get convinced. And same is the case right from the grassroots level at the communities, right at the top level to the policymakers also. So they also would want to see more on these. How do you different sectors, different segments of the society, not only industry, but different sector, different society, different industries, but also different segments of the society. What kind of things interventions can be done and how the numbers add up, or how do they look into the long run, whether it is beneficial. So this also, I mean, we talk about, and the other thing that I would like to see what Dr. Sarkar also kind of touched upon is water neutrality. In climate change parlance, we actually talk about net zero. We all have heard about that, but one of the things that the industries now or several of the other large industries should aim for is also water neutrality, which is something that could be, thought about. Well, not much. I mean, apart from the thing that the kind of lessons that, or kind of stories that have come up recently on the Bangalore thing and the groundwater stress, what Mr. Gandhi talked about. It's not only the groundwater depletion, but also many times it's also how the management of water is there. I mean, I was talking to somebody yesterday in another water conference that the problem of Bangalore was compounded more from the water mismanagement rather than anything else. So that management and collaborative effort, those are the things that I would like to, kind of this thing. Yeah, that's it. I mean, I would like to thank you all once again. Thanks.
Thank you, Mr.
Yeah.
Singh. Actually, you highlighted three critical points, and I would want to reiterate on them again. Firstly, thanks for bringing the perspective of climate change, which we didn't discuss in the morning. I mean, we all know the kinds of, additional, impact or additional kind of problem that the impact of climate change is going to bring. And I think in that perspective as well, one of the things about adaptation and mitigation options, even in adaptation, the focus on efficiency is quite there. And therefore, it makes a huge, impact again, not only for within the sector, improvement and impact, on water management, but also addressing the impact of climate change. You also touched upon very important part, which is cost benefit. We didn't have time to debate that, but I just would like to highlight that's a very, very important point because, unless you have a cost beneficial perspective, intervention or technology into mind, it unfortunately will not propagate. And that's why the role of Bureau of Water Use Efficiency, which Dr. Sarkar as well mentioned, would be increasingly important as we move ahead. If you look into the Bureau of Energy Efficiency example, there was this barrier of cost when we talked about the CFL or for that matter LED. But then there came an agency which had some subsidies introduced. But as the economy of scale came in, this became very much viable. I think that's something which we hope that water sector as well will be able to I think that's a good initiative, the Bureau of Water Use Efficiency. But I think, as Dr. Sarkar mentioned as well, in their role in future, I think once they are able to take that forward, this will be something that will make a change. I now turn to an industry which is the largest water consuming sector, almost more than 80%, thermal power plants. And Mr. Keker has been, all his life, all his life as in professional life, in NTPC. And we would want to turn to him to share his experiences and the amount of best practices examples that he has not only implemented on ground, taking initiative and leading that, but also what he can share to propagate this entire efficiency and the interventions by and large in the sector. Mr. Keker.
Thank you, Anshuman, and a very good afternoon to this August gathering. Today, I'll be sharing some of the initiatives of NTPC. So, the need of the hour has already been discussed is water conservation and sustaining the water both above the ground and below the ground. So, the coolant traditionally employed for the purpose of condenser cooling has been water, since it was normally inexpensive, efficient, and abundantly available. However, this is not always the case. So why we talk about air-cooled condenser? Earth's most precious resources, even available for human consumption, is limited. Priority for irrigation requirements. Cost of natural water presently varies from 5 rupees to 30 rupees per kiloliter across the country. And STP water, presently rupees 100 per KL, is increasing gradually day by day, favoring a tilt towards ACC. ACC is air-cooled condenser. Selection of cooling technology for use in power plants is an economic decision which is frequently influenced by local environmental factors and government policies. ACC feasibility is based on certain economic criteria, that is the water availability and the cost of water. Water requirement of an ACC plant reduces up to 70 to 75% as compared to a conventional condenser. So in this slide, we can see water consumption in a power plant. You can see the raw water to the tune of 3,880 tons per hour. The maximum consumption is in the cooling tower, which is almost 64 to 70%. Next one is in the FGD, 7 to 10%. Third one is CHP, about 5 to 6%. Ash handling plant, 15 to 17%. So these are the areas where the maximum water consumption is being done. So now, NTPC with an installed capacity of 75,418 megawatt, with approximately 25% of share in India's generation, is an integrated power major. Recently, NTPC achieved the milestone of generating 400 billion units in a financial year. This is the ever highest generation by NTPC since its inception. North Karanpura in Jharkhand marks a milestone as India's first air-cooled condenser installed supercritical plant, demonstrating NTPC's commitment towards water conservation through the 3 Rs, that is reduce, reuse and recycle. This project has been envisaged with air-cooled condenser, which was almost 1/3 water footprint as compared to a conventional water-cooled condenser. This is a recent photograph of the North Karanpura, 3 into 660 megawatt, where 2 units are operational, 3rd unit erection is in progress. This results in water saving of around 30.5 million cubic meters of water annually. This is fulfilling the needs of around 1.5 million people living in that region. The groundbreaking initiative signifies technological advancement and also underscores NTPC's commitment to sustainability, offering a blueprint for a water-conscious and efficient future. NTPC has already taken a series of measures across its plant locations on sound water management. NTPC will further imbibe the 3 Rs for water conservation and management while carrying out its core business activity of power generation. NTPC is a signatory to the prestigious UN Global Compact CEO Water Mandate. NTPC is committed to proactively address water sustainability issues through implementing of its water policy, which will serve as a directive for establishing water management strategies, systems, processes, practices, and research initiatives. So we talked about the air-cooled condenser. Since it's a new technology, I would like to share how it does work. An air-cooled condenser is a direct dry cooling system where steam is condensed inside the air-cooled fin tubes. The cool ambient air flows outside the fin tubes is what removes the heat and defines the functionality of an ACC. In thermal power plants, the steam from the turbine exhaust flows into the ACC where condensation occurs. Then the condensate returns to the boiler in a closed loop. Since the steam coming from the turbine is at a low pressure, the ACC works at a pressure close to a vacuum, and non-condensable gases are removed continuously by an air evacuation plant, which can be mainly a vacuum pump. Here, the slide again shows what we have already seen. Air-cooled condenser is a direct dry cooling system where steam is condensed inside air-cooled fin tubes. Exhaust steam flows through large diameter duct to steam distribution header, feeding several vertical risers. Each riser delivers steam to a steam distribution manifold that runs horizontally along the apex row of fin tubes. Air-cooled exchangers exchange heat, and of course the steam is cooled. This is again a photograph of the ACC plant. The only thing you can see is after generating power in the turbine, the steam comes to the low pressure turbine, wherein normally there's a condenser below that, and it is cooled by water. So steam gets condensed there. In this case, there is a condenser where the steam gets accumulated. Then you have a duct. Through the duct, it goes to the air-cooled condenser plant, wherein you have fans. By use of fans, you condense the steam. This is a photograph of North Karanpura, where you can see the duct is bringing the steam to the top, and at the bottom you have a rows of fans to cool the steam. This way, the steam gets cooled, and of course, it becomes condensate and is recycled back. Let's talk slightly about the ACC operating philosophy. The steam flows through one large diameter duct to the condenser. So in the picture on the right, you can see that there is a duct at the top where steam is gradually flowing. Duct system branches into risers and steam distribution manifolds. Steam enters from this distribution manifold into the fin tubes at the top of the primary condensing bundles. Steam is condensed during the downward flow in the tubes of the primary bundles. Condensate and remaining steam are collected in large size headers. Remaining steam is non-condensable enters the fin tubes of the secondary bundles. So you have two types of bundles, the primary bundles and the secondary bundles. In the primary bundles, the main condensation takes place. Then you have the secondary bundles. Finally, the non-condensables are taken to the top and removed. North Karanpura ACC construction is based on a single row tube A-frame air-cooled condenser. It has 10 A-frame type streets of fin tube element. There are 9 modules. Each module is composed of numbers of fin tubes. This is the photograph of the North Karanpura model. Here you can see the difference between a conventional condenser and the ACC is below the load LP turbine, you have a hot box. Instead of the condenser, we have a hot box. From the hot box, you have an exhaust duct. The exhaust duct is carrying the low pressure steam, which is the exhaust of the LP turbine. This is condensed. After condensation, the condensate comes into the drain tank, and by means of the drain pumps, it is taken to the deaerator, then to the condensate, and it comes back into the normal cycle. These are some of the constructional features of North Karanpura air-cooled condensers. Now you can see the size. Since it's an air-cooled condenser, the size is 132 meter by 131 meter. We have 25 numbers of columns. Each column, there are a number of streets, 10 streets. Each street consists of 9 modules. So when a conventional water-cooled condenser is quite compact and small, the air-cooled condenser is gigantic, 132 by almost 132 meters. These are details of the bundles. Now, 2 units are operational. These are photographs of the air-cooled condensers. The third unit, of course, it is under erection. Some photograph of the steam water circuit. These are the constructional features and the operating details of the ACC. Now I have come to the slide wherein I am showing a comparison between the conventional condenser and the air-cooled condenser. You can see the water consumption in a comparative plant of Khargone, where we have 2 units of 660 megawatt, and North Karanpura with 2 units of air-cooled condenser. In Khargone, the water consumption for the year would be 40 million cubic meters, while for North Karanpura is only 15. Since the water has a better specific heat, the cooling is better, so you have a lower unit heat rate. You have a heat rate of 2070 kilocalorie per kilowatt hour, whereas same for North Karanpura is slightly on the higher side. It is 2237 kilocalorie per kilowatt hour. Consequent to a higher heat rate, this coal consumption, specific coal consumption is also on the higher side. For Khargone, it is 7.1, while for North Karanpura, it is 7.9. Since coal consumption is on the higher side, naturally CO2 emission will be also on the higher side. It is 12.8 for Khargone and 13.5 for North Karanpura. Since the coal consumption is on the higher side, milling plant will also operate more. That is why you have slightly more APC also. APC for Khargone is 6.25%, while for North Karanpura is 6.75%. But then what we have seen is water consumption is drastically low. That is because the water availability was a major factor at North Karanpura. That is why the company decided to go for an air-cooled condenser. Thank you.
Thank you, Speaker. I think thanks for sharing this example, because this is one of those, I think, lone initiative as of now in India, which is actually on shifting to air cool condensers. But as I mentioned in my initial remarks, I think these are the good examples. The more we interact on them and the more we share these examples, I think that's where the critical mass impact will come into play. We have overshot the time, so I'll not try and summarize the discussions, but I'd like to thank our panelists, who had been, here out of their busy times and tried and share the critical points about the theme on what is efficiency. Let's have a round of applause for all the speakers.
Thank you to all the panelists for your engaging discussions. And I would like to add, standing in front of the esteemed panelists, as I've started my career as a researcher and urban planner recently, I've understood the, water resource, how important is water resource efficiency and water resource management. And with that, we would like to move forward as we have special events lined up, starting with the unveiling of a policy brief on benchmarking industrial water use efficiency in India. Please join me in welcoming all our panelists for this significant unveiling. Please.
We just recently completed, it's on benchmarking industrial water use efficiency in India. The attempt is to see what are those kind of interventions or low-hanging fruits which can be adopted, and what is that benchmark that can be, inspiration for these water-intensive industry sector. So the copies will be available to all of you. And copy will be available at our website as well.
Thank you. Thank you, sir. Thank you, our esteemed guests, for this valuable unveiling.